Hello everyone, I am Srinaksha, student of SBCE from the Department of Computer Science and Engineering. Well, in this video, I am going to discuss about probability distribution. Probability distribution, exploring the world of uncertainty. First one is exhaustive events. It covers all the possibilities. An exhaustive events refers to a set of events that collectively encompass all the possible outcomes of an experiment. An example, when rolling of a six-sided die, the exhaustive event would include all the possible outcomes, that is 1, 2, 3, 4, 5, and 6. Next one is mutually exclusive events, one or the other. Mutually exclusive events are events where the occurrence of one event includes the possibility of the other event happening simultaneously. Example, when the coin is flipped, the event head and tail are mutually exclusive because only one outcome can occur at a time. Application of mutually exclusive events are fundamental in various fields such as statistics, probability theorem, and decision making process. Independent events, unrelated outcomes. An independent event is one where the outcomes of one event does not affect the probability of other event occurring. An example, when rolling of a die and slipping of a coin, the results are independent as the outcomes of one does not influence the other. Let's see an example in real life. Consider drawing a blue marble from a bag and then rolling a dice. These events are independent since the first action does not affect the second. Next one is probability function. Probability function provide a mathematical representation of the likelihoods of the different outcomes in a same sample. Some well-known probability function includes uniform distribution, normal distribution, and exponential distribution. Application. Probability functions are used in various fields such as finance, data analysis, risk assessment, and quality control. Random variables. It covers the unknown. Random variable is a variable that takes on the different values based on the outcomes of the random value or the event. Types of random variable. There are two types of random variables, that is discrete random variables or continuous random variables. Discrete random variables means taking on finite or countable value, whereas continuous random variable takes on a value within a range. Application. Random variables are widely used in probability theorem, statistics, and various scientific and engineering applications. Next one is mean, variance, standard deviation, measures of central tendency and dispersion. Mean. The mean of a random variable represents its average value and is calculated by summing up all the possible values weighted by their respective possibility. Can see here, mean mu is equal to summation of x into p of x. Variance. Variance measure the spread or dispersion of a random variable's distribution and is calculated as an average square difference between each value and the mean. Variance is equal to summation of x square into p of x minus nu square, that is mean square. Standard deviation. Standard deviation is the square root of variance and provide a measure of the average distance between each value and the mean. We can find standard deviation by using square root of summation of x square into p of x minus nu square. Next one is binomial distribution, success or failure. Binomial distribution models the probability of a certain number of success in a fixed number of independent. Example, flipping a coin multiple times and counting the number of head will follows the binomial distribution. Let's see an example in our real life application. Binomial distribution can be used to model the probability of success in quality control process. Next one is Poisson distribution. Poisson distribution models the probability of a given certain number of rare events occurring in a fixed interval of time, space, or other units. Example, the number of emails received per hour or the number of accidents per day on a particular road can follow a Poisson distribution. Real life use. Poisson distribution is applied in a field such as insurance risk assessment and analyzing website traffic. Next one is continuous probability distribution, smooth and continuous. A continuous probability distribution describes the probability of a continuous random variable across an infinite range of possible values. An example, well known continuous probability distribution includes the uniform distribution, normal distribution, exponential distribution, and many others. Application of continuous probability distribution are extensively used in the field of physics, fi- finance, engineering, and environmental modeling. Exponential distribution. The exponential distribution models the time between the events in a Poisson distribution process where the events occurs at a constant rate and independent of each other. An example, the time between the phone call received at a call center or the time between the arrival of a customers at a store check checkout can follows the exponential distribution. Application. Exponential distribution is used in various fields including queries theorem and survival analysis. Thank you.